Okay, before we are starting the session, just a logistical announcement. So after the last session today, everybody is welcome to go together to National Museum of Arts. That's in all the Stock Exchange building, or the Burrs building in the Dome Square. So if you are interested to go together, so I think the most reasonable place and time might be 10 to 7 in the Hotel Conventhof. I mean, that's the hotel where most of participants are staying. So, okay, that's actually the only announcement I wanted to say. So, if somebody is interested to join, so we could go together to Art Museum.
Is it on? Yeah, okay, very good. The pleasure of chairing this final plenary session, and it's my pleasure to introduce Barbara Landau, who is Dick and Lydia Todd Professor and Director of Science and Learning Institute at Johns Hopkins University. Barbara?
Is this going to be, oh yeah, this is okay. Okay, great. Good. So thank you for coming, and thank you for Jurgis for inviting me to this very interesting set of talks, symposium. I'm going to talk about the origins and development of spatial language and emphasize some complexities that I've been thinking about. So I want to start out with an obvious observation. Spatial language is powerful. It has powerful uses. So we have lots of applications. We can use spatial language to show a toddler how to stack blocks. We can use spatial language to help us assemble furniture. We all follow directions when we get furniture from IKEA, say. We can hope to instruct robots to put a box on a pallet, although that's actually a tremendous challenge still to get a robot to understand human spatial language. Nevertheless, it is very powerful. And my major question over all of these years is how it's learned. And there are two views of the foundations for spatial language learning. One is what I'll call the universals view, and that is the idea that the origins for learning spatial language are a set of pre-linguistic spatial concepts that are deeply rooted in human spatial representation. And I have a graphic here from a paper that Ray Jackendoff and I wrote some years ago called What and Where, and what's being emphasized here is that the major axes of the human body are clearly natural structures that can be drawn upon for spatial language. So that's what I mean by deeply rooted pre-linguistic spatial concepts. The other view, which has been prominent in the field, is what I'll call the language-specific view. And this is the idea that, based on the observation that there really is considerable variation in how spatial relationships are encoded across languages, there have been hypotheses that the origins have no special categories. That is to say, you're not born with pre-linguistic categories that will be used for spatial language learning. Rather, they're constructed through linguistic exposure. So in order to understand, in order to learn what the spatial categories of your language, you simply have to hear your language. There are no constraints on those categories. The universals view is one that I'm going to espouse. I still believe it's true. I've got a little clip here of the view that Ray Jackendoff and I put forth in the early 90s. And in that view, we said geometry is key. And we talked about a set of features that we proposed would be universals that could be drawn upon, including direction and relative distance, and construals or representations of objects that would include their axes, volumes, surfaces, points, and lines. We also at that time talked about what we called other factors. This was sort of like what we couldn't account for, and that included force dynamics, such as relationships of support and containment, and cultural construals of reference objects. I'm going to come back to that in just a bit. But we did say that we did inventories of spatial prepositions, found there are really very few across languages. English has probably one of the largest stock across all languages, and there's something like 80, including a lot of compositional ones. So really, if you boil it down, you could get down to about 24 notions. And we said there are so few prepositions because the notions that they can mean is just extremely limited. Now, this view, the universals view, has actually been challenged from a number of different perspectives. One challenge is the widely cited observations of cross-linguistic variation. And in truth, I don't personally think they're serious challenges because the universals view actually doesn't only aim to account for what's the same across languages, it also aims to account for what varies. But some of the examples that have been given in the literature are, one, the fact that languages vary even in how they encode very simple relationships, where relationships such as containment and support. And I think this graphic from Levinson et al. Is probably pretty hard to see, but it basically shows pretty straightforward spatial relationships such as an apple on a table, a ball under a table, a stamp on a letter. And Levinson and others have pointed out that even those very apparently simple spatial relationships really are, the domain is cut up in somewhat different ways across different languages. So that's one challenge to the idea that there are universals, perhaps. A second challenge, and one that I'm really going to focus on today, is an observation that was initially made by Melissa Bowerman and Soonjit Choi, and has been very widely cited in the literature, and that is the idea that some languages encode distinctions that other languages simply don't. And the example that they have focused on and that's been very, very widely cited is the idea that Korean, for example, encodes tight and loose fit relationships for location, but English does not. That's the claim, and I'll be talking much more about this. So these challenges, that is the variation in cross-linguistic, the cross-linguistic variation, are one kind of challenge perhaps to the idea of primitives and universals. But I think a stronger challenge is actually the inferences that people make from this variation. So Levinson et al., for example, say that the differences between the languages turn out to be so significant as to be incompatible with the stronger versions of the universal conceptual categories hypothesis, essentially saying it doesn't make sense to talk about universals if you really have such widespread cross-linguistic variation. In terms of the tight and loose fit exemplar, McDonough, Choi, and Mandler have taken this one step further into the language and thought domain and have claimed the results from adult non-linguistic sorting data support the view that the language we learn can influence thought. So this challenge is really the idea that if you're learning a language with very different spatial, that encodes spatial relations very differently, it's actually going to change the way that you think about space. So those are the stronger inferences, I think, from cross-linguistic variation. Today what I'm going to talk about is the powerful role of combinatorics, which I think that I actually heard a very interesting talk in a session earlier today on combinatorics. I think it was vector semantics. I think that we too often in acquisition forget about combinatorics. We think about the meanings of terms like in and on without thinking about the combinatorics. And I want to bring us back to thinking about combinatorics and show how important it is, not only for the universals view, but also the language-specific view. So for the universals view, what I'm going to argue is that the prelinguistic space, rich as it is, doesn't actually bear a very simple mapping to the semantic space. You actually have to learn something. You have to land a semantic space, not just use the prelinguistic space. And for the language-specific hypothesis, the idea that I'm going to promote is that actually universal meanings are encoded across languages through words and their combinations, and that once we start taking account of the combinatorics within each language, then we actually see much more equivalence than we might think we see if we're just comparing word to word. And the simple proposal that I'm going to make throughout the talk is that composition matters. I'm going to say that the view that Ray and I put forward in 1993 is still basically correct, but I am making a friendly amendment. And so whereas we said that there was mostly geometry and that there was other stuff that was the functional, I now think that spatial adpositions actually form two core classes. One, the geometric, I want to say is rooted in navigation, in the navigational system, and mainly because the core concepts here are about distance and direction, those things that we really need to navigate and to find other things, to navigate to find things. But there's another really important core class, and those are functional relationships. These are, interestingly enough, not what one has called topological in the past. We talked about that a little bit in the previous session, but rather they're force dynamic and they're rooted in object knowledge. They're rooted in knowing what objects do to each other, how they interact, and so forth. So I'm going to use the example there of containment and support. But the most important message is that spatial terms also combine with other elements to fully express spatial meanings, and that's how we get to equivalences across languages. I'm going to give you 3 examples of why combinatorics is important, and I'm going to zip through the first 2 and then spend most of the talk talking about the 3rd example, in which I'll give you fairly rich data to show what I mean. The first point, the first example is that basic spatial terms, things like in and on and under, may only actually be very narrowly anchored in infant spatial concepts. Combinatorics of the language is actually crucial even in early language learning, and I'm going to give you a very quick piece of evidence on that. The second is that full acquisition of spatial terms, even things like in and on and under, actually requires combinatorics, and this process of acquiring the combinatorics follows a maturational timetable that's actually very similar to morphology and syntax, which makes it a really interesting case because it's spatial, and so one thinks it's more like open class, it's more like accessible to a cognitive domain. But on the other hand, it acts like aspects of language that are closed class and much more rooted to sort of the biology of the learner. Then finally, the main thesis is, the example that I'm going to give is that it's combinatorial even from the start, and even for the hotly contested example, the tight and loose fit example, languages do encode similar thoughts if you allow them to use the lexicon, the morphology, and the syntactic frames. And looking at that combinatorics is a crucial part of learning. First case, very quickly, basic spatial terms may only be narrowly anchored in infant spatial concepts, and to understand spatial language learning, combinatorics is crucial. And it's really just 2 slides I'm going to give here. One is that the narrow anchoring that infant psychologists, developmentalists who are interested in infant cognition, usually look at are things like containment and support, and they do tests that are very, very clever to examine prelinguistic infants' knowledge of containment and support. But they look at things like, for example, inserting one object into another or removing one object from another, taking it out. Or they could compare, for example, the knowledge that an infant has when one object is lowered into another versus lowered behind another. And they might compare that, for example, to when one object is lowered onto another support system. So these are very basic, very grounded physical exemplars that give us the information that we have on infant cognition of things like containment and support that could support in and on. However, this is what's learned. And this is the example of just doing a corpus search with the word in. And not just looking at the number of instances of word in, but the combinations that are produced by children who are between 1 year, 9 months, and 2 years, 8 months. Okay, so these are really young kids. And so the different categories that we've come up with are things like in a vehicle, so in a car, in a taxi, in a boat, in a fire engine. These are all attested. Places, in a hall, in a garage, in a kitchen, in a town. Media, so in hair, in air, in the sky, in fire, in water, and temporal uses, so in a minute, in 2 weeks, and in the morning. So given that, we know that children who are 1.5 years to 2 years old already are using the term in, not just for these insertion cases, but for very, very abstract cases, and we need to know how that happens. So that's the sense in which the combinatorics of what they're learning is really, really crucial. It's not just learning about inserting one object in another. The second example that I'm going to give you is this idea that the full acquisition of spatial terms requires combinatorics, and in order to account for native language learning or full language learning of the spatial prepositions, you have to account for not only the prepositions but their combinations with reference objects. And when you look at this closely, you actually find that people who learn their language after the age of 8 are increasingly more poor at acquiring the native distinctions. So all of us learn all of the distinctions if we learn from our native language. But for second language learners, it's actually, some of these combinations are extremely difficult. And I'm sure there are many non-English speakers, so some of these examples will really ring true in terms of being really, really difficult to reconcile with sounding natural. The study that I want to just really briefly tell you about is one that was carried out by Ed Munich and I a couple of years ago. We published it in Language Learning and Development. And we tested 60 adult participants, 30 native speakers of Spanish and 30 of Korean, and they were all tested on English spatial prepositions. These 2 groups varied by the age of immersion in English. So they're all living in the States, but they vary in terms of when they learned, when they were exposed, when they were immersed into English. So a third of them were early learners, that is, they learned their age of immersion was 8 or younger. A third were mid-learners, age of immersion was 8 to 13. And a third were what we called late learners, and the age of immersion was 13 and older. So young learners, mid-learners, and older learners. These are people who, at the age at which they're immersed into English. Okay? And we tested them with a production task and a comprehension task. I'm only going to tell you about the production task because I'm going to show you very little data. The production task just presents them with scenes and says something like, we show this scene, and then we say the ball is blank the can. So in this case, clearly it's in the can, right? It's on top of some tennis balls in a can. In this case, it's on the can. But we also have much more subtle cases. So for example, we have I can't see what the thing is. Oh, it was the owl in a tree. So we have the owl is blank the tree. And for English speakers, it's very natural to say the owl is in the tree, to fill it in with an in. But actually, for second language learners, late learners, it's not at all natural. We compared that, for example, to a bird on the branch. That's very natural for English speakers, and seems to be somewhat easier. We had other cases like women in a kayak, versus people on a flight. So taking different conveyances where in versus on is the most natural element to use, the most natural preposition, but these are really, really subtle things. They're not things that we would hit us in the face with. For cracks in the road, but a yellow line on the road. So depending on what your figure object is, you'll use an in or an on. And we tested people on their production of these things, and we looked at the effects, their accuracy in terms of the age of immersion. So first I want to tell you that we also did the study, to begin with, we did morphosyntax. So we took a study by Newport and colleagues, and we just replicated that to make sure that our participants were performing the way they should. And so on the morphosyntax tasks, that is things like judgments of grammaticality for word order, plurals, use of auxiliary, and so forth, you see exactly what Newport and colleagues found, which is this is the age of immersion here, and this is the score going from low to high. And what you can see for both groups, the Korean and the Spanish groups, as you have a later age of immersion, as you start learning English later, you're worse as an adult, and this is after using for at least 10 years. You're worse at plurals, auxiliaries, and so forth. So that confirms what Newport found. What we found that we thought was actually very surprising was that we got the same curves, basically, for the spatial terms. So there are some that are very, very acquired very early by early learners and late learners, but as you, each of the dots actually is an instance. That is to say, it's a scene where you would ask to elicit a term. But as you get older, as you have a later age of immersion, your scores go down in exactly the same way that it occurs for morphosyntax. So what this means is that the combinatorics, not just knowing when something goes in something or when some object is sitting on a table, but the rich combinatorics is really actually a huge challenge for late learners of a language. So we have to take into account combinatorics. So point one, young kids get it, and it's an important part of the learning problem. Point two, it actually seems to be run by some kind of a maturational or biological timetable where late learners really find it very challenging to master a lot of these combinatorics. Okay. Now I want to move on to the third and most explicit case, which is going to be the celebrated case of tight and loose fit that I mentioned initially. And this is again going to be a story about how if we think that different languages use different terms and code different distinctions, and if we only look at single words, we're actually going to be missing a lot. If we use the combinatorics, if we use not only the prepositions but the verbs and the nouns and even the syntax, we actually get a much richer and much more equivalent view. So this is work that has recently been completed by Özge Gorjanli and Colin Wilson and I. We're writing it up for publication even as we speak. And it's going to be taking the case that Bowerman first pointed us to and examining that in close detail. So again, the widely cited observation from Bowerman and Che is that Korean encodes joining and separating events in terms of what they call loose versus tight fit, while ignoring in and on, which is an English distinction, and English appears to do the reverse. And the example that they use, these are our graphics or our exemplars, but this is basically their cross-cutting hypothesis that there's a verb kita and a verb neta in Korean that distinguish between things that have tight fit with each other, so two cups nesting in each other, one inserted into the other and it's tight fit, also one Lego attached to another, it's inserted and it's tight fit. Those are captured by the Korean verb kita, and then there are more loose fit ones, one small cup into a large cup, or one Lego, on the other one, but not in the attached sense, so the loose ends fitting. So there's that distinction for Korean, and the claim is that English has the cross-cutting distinction for containment. These are both containment, and one says put in. And these are support, and one says put on. So again, the claim is that there's this cross-cutting distinction such that Korean encodes tight and loose fit, and English does not. So the supporting data that Bowerman and Che first provided, which was in elegant studies where they created a wide set of objects, and they showed participants that they were either putting them together or taking them apart, joining them or separating them, and then they just asked them to describe, what did I do? And this is the data from the Korean-speaking adults, and all you have to see, I know you can't see the details, but all you have to see is that this set, this domain space is actually quite finely divided. Some of the ones that I think are really important are there are two Legos, for example, that are being attached this way and being put together. Those are captured by the Korean verb kita, whereas, and same thing with joining pop beads and other tight fit, whereas some of the loose fit ones are way over here, and they're either nota or neta, so putting loose objects in a bag and so forth. So you do see these distinctions in Korean adults. The comparison is English-speaking adults who have the same stimuli, and they have a much coarser field, it looks like. It's cut up in a much coarser way. So Bowerman and Che emphasized that English-speaking adults actually say a lot of these, put some verb plus on, and then some verb plus in. They talk less about some verb plus together, but that's actually going to be very important in just a bit. So these are exactly the same instances, but they're sorted in a much more coarse way by the English-speaking adults, and there doesn't seem to be, other than this region here that I'll talk about, a lot of fine distinctions that are engage verbs of tight and loose fit. So based on these data, again, the conclusion was that Korean encodes a distinction which English tends not to, and although I think that those initial observations are really, really important, I think that it's worth looking very, very closely at the data, because I think the data actually tell a different kind of story. So a few points based on the Bowerman and Che figures. The first is there were loose fit items that were things like boat in a bathtub, putting Legos in a bag, putting toys in a suitcase, putting blocks in a pan. For those objects, for those sets of events, actually both Korean speakers and English speakers uniformly used the same term. And they're things like either loosely put in or put in. Okay, so those are grouped together. It's also the case that for tight fit items, things like joining pop beads or putting one Lego, attaching one Lego to another, there's actually a lot more variation. And Korean does appear to use particular verbs for, especially kita, for example. English adults appear to use the particle together for these. And so there was a space there that had pop beads and had Legos, and those actually got a lot of elicitations of put together from English speakers, English adults. And that clued us into maybe it's not the case really that there's this very large difference in the way that things are coded, but maybe it's that one has to look more closely at how the English encodes things, how they encode tight fits versus loose fits. So the empirical question we asked is just, is it really true that Korean encodes tight fit but English does not, focusing on the English? So to explore this claim, we first just did a really coarse, we took a strong hypothetical version of the Bowerman-Che claim, and we said, okay, suppose it is the case that Korean encodes tight fit and English does not. Then taking these 6 instances, which I'll talk about in a minute, but there's 6 instances from the battery, we would predict that the use of tight fit verbs for those tight fit events, these are all tight fit events, would all cluster up here for Korean at 100%, obligatory. And they would cluster near 0 for English. There wouldn't be tight fit verbs for English. So this is just the hypothetical. They would all belong in this corner. As it turns out, the actual data from Bowerman's graphs show that it's not obligatory in Korean. It's about half of the subjects use the tight fit verbs for items like putting together Legos horizontally and even putting together pop beads. Some of them are sort of half and half loose verbs and half tight verbs. There are others that are much more tight verbs, but already we see that they're optional and not obligatory in Korean. We also have to note that in this study, the comparison that Bowerman and Shea made was between Korean verbs and English prepositions. So the point was that in and on are the terms that are used very early by young children, so let's compare in and on with the verbs that are used very early by children in Korean, so kita, for example. And so that's a little bit apples and oranges, and we decided we needed to look much more closely at both verbs and prepositions. So our approach was to examine the options in English. And we did 2 experiments. One, a stimulus set with balanced properties, because we're good experimental psychologists and we didn't like just having sort of havoc in the instances that we used. And then in order to see whether or not we were just biasing things by having this very balanced set, we also did tried to do a replication. So a second follow-up experiment was a subset of the Bowerman and Shea original stimuli. We just got the same stimuli and we carried out the same experiment with those. And our analyses, I forgot my water, which I'm going to need in a minute. The analyses, actually, is there something over there that's drinkable? Oh, there's one that's not closed. That's great. Thank you. See, that's why you need somebody to introduce you. So, thank you.
At your service.
And I will do it for you tomorrow. The analysis for the linguistic options were English verbs and then also syntactic frames. So we're not only going to look at the prepositions, but also the verbs and the frames in which they're used. So just to give you a sense of what the stimuli look like, here is experiment 1. These are 12 English-speaking adults and 12 English-speaking children, and we show them videotaped events such as this, where this is a loose fit together, joining loose fit. So it's 2 Legos, but they're opposed to each other, so they're not nesting together. And then you just say what happened. And then in experiment 2, where we added things like pop beads and other kinds of stimuli that Bowerman and Shea had used, it looks something like this. It's another joining event. This is a tight fit joining event. Show them that and then say what happened. So they're all videotaped events. Everybody sees all of them and describes them. The experiment 1 had balanced stimuli. As I said, it was nicely sort of crafted because we're good experimentalists. And we had joining and separating. We had tight and loose fit events in both joining and separating. And then we added one a parameter, which was symmetry and asymmetry, because one of the things that we noticed with Bowerman's stimuli was that a lot of the loose fit items, both in English and in Korean, were stable things into which some small thing had gotten put. But a lot of the things that elicited tight fit verbs and also together in English were things where there were equal sized and identical objects and they were moved towards each other symmetrically. So we added asymmetrical motion and symmetrical motion. Okay, so you just saw one asymmetrical motion where one Lego is placed on the other and one symmetrical motion where they're moved together. So they're all together 24 events and children and adults are shown these and they describe what happened right afterwards. So the first analysis is the verbs used for tight-loose events and the syntactic frames that are used with these different verbs. And what I'm going to show you now is a pie chart in which what we've got for adults for the joining verbs, for the joining events, I should say, to begin with, basically what you should be looking at, or what I'd like you to look at, is the big, huge swath of territory that's the same color. Okay? So there's a swath that's the same color up here for loose asymmetrical and also for loose symmetrical, but as we get down to tight symmetrical and tight asymmetrical, we see that the swath gets smaller and these other colors begin to fill in. So what the big swath represents is very general terms, things like put and place. All of the other terms, the terms that are, actually this should be a color of purple, sorry about that, but all of the terms that have varying degrees of purple and are different shades are actually much more specific verbs. So things like balance and slide and connect, for example. So what you can see is for joining events, adults actually separate between loose and asymmetrical events in which there are lots of these general verbs and tight symmetrical events in which you can use them too, but you also add a lot of much more specific verbs. The same thing happens for the separating events, again the adults. So loose asymmetrical has a big swath of these very general verbs like take and separate. And as you get down to tight symmetrical, you get fewer and fewer. So you get a much larger swath actually across all of these, both for symmetry and also for tightness. You get more of the verbs that are much more specific. Okay? So there's a shift in the balance of what verbs are going to be used. The children did much the same thing, but I'm not going to show you the children's data until we get to experiment 2, which is now. Mostly, I have to say, the children's lexicon is much smaller, so their verb range is much, much smaller. So there's less variation than we see there, but you get the same pattern. Experiment 2, which was the follow-up, was 24 joining and separating events that followed on the Bowerman and Shea work and also on Rigier and Zheng's work, who used the same stimuli as Bowerman. And so these events were things like joining events such as car in the box, putting a doll on a tissue, putting Legos in a bag. And then there were a set of these bolded items which all elicited tight-fit verbs in Bowerman and Shea's study. So cassette in a case, a cap on a pen, pop beads together, and a puzzle piece in a board, all things that would be tight-fitting. So we used those 12 events, and then we did the reverse for separating. This is another look at the verbs. Again, these are adults. And again, what you see is the very, very general verbs for loose and asymmetrical events, when one thing goes like that. And as you move down to tight fit, and especially tight symmetrical, you see that the very, very general verbs get reduced. And what you have taking over is much more specific verbs, including things like lock and connect, which express something like tight fit in English, apparently, or are used to express a tight fit relationship. The separating events for adults, again, looks the same. Most of the general verbs are for the loose asymmetrical, and it changes with many more specific verbs for tight symmetrical. So it looks like there's a change in the balance of the use of the kinds of verbs we have, depending on whether the event is tight or loose fit. These are the data for the joining verbs for children. So for children, there's much less variety, as I said. This is loose asymmetrical, and there's get and put is almost everything. For children, but you do see for tight symmetrical, you begin to have things like unstuck. This is actually joining. Children do confuse the to and the from. But attach and connect. So you get more of these more specific verbs when you get a tight fit event. And the same thing happens for the separating events, where you have very huge swaths of the general verbs for the loose asymmetrical, but when you get to tight symmetrical, you get more of the specific verbs. So we decided to also do a direct comparison of our data and Bowerman's, and we analyzed the six tight fit events that were common to our study and Bowerman's, and these are they. Pop beads joined, a cap was put on a pen, a puzzle piece in a puzzle, a cassette in a case, Legos were joined side to side, and Legos were joined vertically. And they came from different experiments, but we pulled out the data on those and compared them exactly to what Bowerman and Shea had found. So again, here is the data that I showed you originally, where we just took from their charts and we said, what's the proportion of people who are using tight fit verbs? It does depend on what the item is, and it looks something like this for the Korean data. So it goes anywhere from 50% all the way up to 100%. And then over here, we have our English data, and this is all the verbs that were used across these events. And these verbs were used exclusively for tight fit events. So we get attach, cap, close, connect, fit, press, link, and insert. And they're only used for tight fit events. They're simply not used for the loose fit events. So this, again, says that there are more specific verbs that are used freely by adults when they describe these tight fit events. And the same thing happens with children, but the children's lexicon is much, much smaller, so you get many fewer episodes. That means that when we plot them against each other with their Korean data and our English data in terms of proportion of participants, we get something that looks more like this. This is the line of equity, where if things fell along the line for every single one of the events, it would mean that Korean speakers and English speakers in the studies use about the same proportion of tight fit verbs. So it does look like there's more of an effect. There are more tight fit verbs that are used by, or I should say, Korean speakers tend to use tight fit verbs more frequently overall in these events than do English speakers. But still, you can see that there's a pretty good variation, and there are some events, such as this one, the pop beads and the Legos being fitted horizontally, that actually elicit about the same proportion of tight fit verbs. To summarize for the verb analysis, we get put, place, push, take, and separate, the general verbs, which can be used for both tight and loose events. But connect, attach, link, insert, and detach are only used for tight fit events by English speakers. Okay? So they are specialized for the tight fit situations. And you can imagine if you were putting a pen into a cup, there's no way it would be very odd to say I inserted the pen in the cup, unless it was something that was a tight fit. The second analysis we did was syntactic frames. And so this is independent of verbs, but it cross-cuts the verbs. And we did an analysis that looked at the number of, the way that the objects in the two objects that were being put together or fitted together were encoded, either each one with its own NP, so object 1 as an NP1, object 2 as an NP2, and that's, for example, in the frame VNPPP, she put one cup into the other cup. So two separate noun phrases, each one for an object. And the other frame that we found was predominant was a frame where the speakers collected up the two objects that were being talked about and cast them as one noun phrase. So she took the blocks apart, or she connected, separated two Legos. Okay? And that distinction, the distinction between singly coding, individually coding the two objects as NPs separately, and encoding them as a single conjoined NP seems to actually do a lot of work. So looking at these color coding, what I want you to focus on in the next few slides is the dark one, the black bars, which is going to be each object with its own NP, and then the lighter gray bars, which are all going to be the two objects as cast as one NP. So for adults, in joining and separating, these are collapsed. Experiment 1, what you can see is for loose fit and tight fit, for asymmetrical, symmetrical, asymmetrical, symmetrical, what you get is a decline in the use of this frame with each NP being expressing one object. So something like she put the small cup into a bigger one would be much more likely in the loose fit asymmetrical than it would be in the symmetrical tight fit case. So again, the big contrast is between loose fit asymmetrical and tight fit symmetrical, where you get this real differentiation by use of the frames. The same thing happens with the children, and actually what's interesting about the children is that even though they have very few verbs and they're just beginning to get this lexicon of sort of richer verbs, they're actually using the syntax to do much of the same. So you see the same pattern with the asymmetrical loose fits being things like she put one cup into the other, and the tight fit symmetricals being something like she took the blocks apart. Experiment 2, the Bowerman and Che replication, we get the same effect, again with loose fit asymmetrical having lots of these put one cup into the other, and the tight fit symmetrical going way down in those and having more of the conjoined ones. And experiment 2, the same thing happens with children. By the way, you may be wondering, probably not, but I'll just say, in case there's someone who's wondering why there's not a fourth cell here, symmetrical and loose fit, it's because the Bowerman and Che stimuli didn't have any of those. And so although we balanced things nicely in our first experiment and have all 4 cells, we didn't have that cell because we were using exactly the same events that they used. So they actually didn't make any attempt to do anything that was balanced. They just took a very, very beautiful, very wide, broad set of events that one could look at. So the summary for the syntactic frames is this. As you go towards VNP, you get tight fit events, symmetrical movement, similar objects, as in she connected the Legos or she put the beads together. As you move towards VNP-PP, where there are 2 different NPs, one here and one embedded in the prepositional phrase, you get loose fit, asymmetrical movement, different objects, such as she put one cup on the other. So this combination of forces, both the varieties of the verbs and the frames that they tend to appear in, actually does a really amazingly good job of separating out the tight and the loose fit distinction. Okay, so the summary is that tight and loose fit is expressed in English. We get options such as verbs, connect and attach, frames, VNP versus VNP particle, and the options in Korean are presumably the same set of devices, but we just don't know because that kind of analysis wasn't done, and I haven't been able to find anybody who'd be willing to do the same kind of analysis in Korean. But my prediction is that the same techniques, the same mechanics in the syntax would be used to make the distinction. So returning to the proposal, composition matters is what I wanted to tell you. I wanted to say, yes, I still endorse the idea of primitives that can undergo combination. We might have 2 classes, the geometric and the functional, but the important part here is that spatial terms combine with each other to fully express spatial meanings. And the summary for the evidence on combinatorics is the three stories I've told you. The first 2 very short. First, basic spatial terms may only be narrowly anchored in infant spatial concepts. As soon as kids begin learning, they begin learning things like in my hair. And that can't be accommodated, I don't think, within a strictly geometric, a strictly, infant spatial concept framework. The second is that using the terms appropriately combinatorically actually is really a hard job. You learn it absolutely rapidly and easily if you're a native speaker, but if you're a second language learner, it's actually a lot of cultural construals about the objects. You have to learn which are the things that get considered to be usefully combined with ins or ons, and that's really quite a challenge that's very, very much akin to morphology and syntax. And finally, combinatorics is really crucial for understanding the expression of spatial meanings across languages. Tight fit and loose fit is an example, and learning how to express all these relationships has to take into account combinatorics. So to rethink the problem, we can get a sparse representation of where, I claim, conveyed by the adpositions, really rich representations of what's and hows. So the what's are the noun phrases, the objects, and the hows are the verbs. And their combinations with these where terms create this combinatorial explosion that allows us to make enormous numbers of distinctions way beyond what we would have if we only had the primitives and no combinatorics. And I think that taking this view actually makes us focus more on the combinatorics and leads to a much more nuanced idea about how language encodes location and reveals very rich structure, and of course the importance of compositionality. So to conclude, rich linguistic sources help guide action, show a toddler how to stack blocks, someone to assemble furniture, or telling a robot to put a box on a pallet. Still a challenge to say, put the box on the pallet. I understand from my computer science and robotics friends. But it's only possible if we take seriously the combinatorics that are needed to fully express. And so I want to just conclude and finish by giving you a real example of what happens when you look for the instructions for putting together a trampoline, which I did when I was doing this talk. And this is what it looks like. This is not from IKEA, but IKEA's are actually way worse. So it says loosen the straps, not shown, on the underside of the frame pad, thread a nut jam as far as possible onto a clamp screw, thread another jam nut onto another clamp screw, thread both clamp screws, repeat this step with all the jam nuts, clamp screws, and clamps, lift one of the trampoline sockets off the leg, slide a clamp down onto the leg, slide the socket back onto the leg, slide a clamp onto each of the legs in the same way through step 8. And for those of you who want to laugh, the reverse, when you get to the end and it says what to do to disassemble the trampoline, it actually says do steps 1 through 8 in reverse. Combinatorics rule. Thank you very much.
We have a lot of time for questions.
So I talk too fast, maybe.
Hi, I'm Peter Gardenfors. I was intrigued by your distinction between the symmetrical and asymmetrical verbs here. And one thought I had was that in the asymmetrical cases, you can make a distinction between what is the landmark and what is the trajectory. Right. While in the symmetrical cases, I mean, you can't make the distinction, so the solution is to make a combined landmark with a plural noun. Mm-hmm. Would that make sense?
Totally.
Okay.
Totally. And what's interesting is that this is purely intuition, but I think the ones with firm landmarks and figures that move relative to them are probably the more primitive. I mean, that's the way that we all think that we represent space at the most fundamental level. So the symmetrical ones require special verbs. Those verbs aren't acquired until a little bit later. But something like together is something that's used pretty productively pretty early on. But yeah, I agree with you completely. That's what the symmetry is meant to capture if you were to think of it as a spatial symmetry and asymmetry. I should just one other thing though, that symmetry actually isn't only confined to space. So Dedry's example of divorcing. Mary divorced John, John divorced Mary, Mary and John divorced each other. So can you really divorce one person without having the other person divorce you? I mean, there's something about the actional voice in the subject that makes you think that you can make these somewhat asymmetric, but the verb itself, divorce, is a symmetrical verb. Yeah.
Thank you very much for this lecture. I have a question concerning now what you call combinatorics. So I understand that you are more interested in cognition, but still there is a pervasive problem. You put two things together, X and Y, and then some meaning emerges. You know, who's saying what, right? You can either say it's in the meaning of X, or you can say it's in the meaning of Y, or you can say, I have a rule of putting together which makes X and Y have that meaning. So that would be, it's not really construction, that term is sort of taken now, but let me put it this way. Let's say you want to explicate the meaning of in or on. I mean, in a dictionary, you would find 12 or 18 or whatever entries, and then you'd say, well, that's the meaning of in, right? But you're saying that's not the case, at least spatially. But I mean, still, it means you have to learn the meaning of in.
Yeah, you do
right?
have to, right, you have to learn it. So one thing I want to just address first is your comment that the combinatorics is either it means this or it means this or it means this and this. I mean, you know, I wish it were that simple. I think that we heard the talk earlier today that said, oh, this, you know, actually the combinatorics even of things like, you know, above and below, which I want to put in another category, but are extremely complex. And so understanding the combinatorics, I don't understand the combinatorics and I don't know how to characterize them. I think it's the same problem as red hair. You know, so what's the combination of red and hair? It's not red and hair, it's something else. And so to really understand what the output is, there's no simple way of making a rule that says it's red plus it's hair, or it's in plus the bucket. The best, you'll have to learn something. One way to think about it, and this is really, I've just been thinking about this, and I don't have anything totally convincing yet, but I mean, it's possible that kids start off with something that's more like what we think of as the in, you know, the good in, that when you look in the dictionary it says contained by, or when you look at on that says supported by, which are not really the meanings of in and on. And then what the child does, they start with that, but then what they're doing is actually a corpus analysis. So it's this massive input that they get from the language they hear around them that allows them in some way that I don't understand to collect up the instances that go with in and the instances that go with on and develop some kind of a, as you put it, a rule for what those things really mean. And so then the things that can be the reference objects for in or on count as containers. I don't think it all helps to say they're containers. I mean, that's just making it circular, right? But so I think it's some kind of combination of maybe starting small and then using the information from the corpus, from the language around them to do, and then, you know, there's the big magical, really hard step of what exactly are they inferring? You know, what's the rule that they're inferring? And I just don't know. I mean, I just think these are really interesting problems that make me think that for most developmentalists, when they think about, you know, how does a child learn in or on, I mean, they think about putting things in buckets. And I come from more of a linguistic perspective where I know it's vastly more complex than that. So if you're interested in the language side of it, you have to be worried about these things. I mean, that's probably a long way of saying, I don't know the answer to your question. Yeah, Deidre.
That was really interesting, Barbara. So I have a question about, way back to the beginning of your talk, you talked about how even before the age of 2, you hear kids using in and on with very different kinds of ground objects, for example, in the hall, in the pan, and so on. Do you think I don't know how to put this, so I'll just say it very intuitively. Do they think of this in as the same word, do you think, or have they learned a holistic phrase? You just say in the hall, or do they think there are several that this word has several different meanings? What do you think?
Melissa actually had some beautiful data on that. I mean, it was sort of a throwaway sentence in one of her papers. I mean, always so insightful. Where she said I think it was Dutch kids, and maybe you know this fact as well, either Dutch kids or, I think it was Dutch kids, where they have the adults have the word uit, which means you take your shoes uit your feet, take your shoes out of your feet, which means like, it's crazy. And so she said that actually early on what the kids did was they formed a single category in the sense that they used them both, but it was this way too big. And then it gets shrunken down, and then when you ask an adult, why do you say uit your shoes, they say, that's really weird, I don't know why I say that. So some of the ones are going to be just like stragglers, idiosyncratic like things that you just learn them. But as far as the more principled ones, I mean, those are the ones that it's in a sense harder to figure out.
Yeah. Well, as I read Melissa Bowerman's paper on that, I thought she thought that they started separate. There were these two uses that at first were learned separately,
Yeah,
and
so
then
maybe
at
I
some
got it
point
wrong.
they began to think there should be, to see that actually they were using the same word, and then they tried to put things in the middle, so to speak, which turned out to be kind of unacceptable.
Yeah.
And I'd have to look at the paper
Okay,
again, but
yeah.
yeah.
So, but I don't know if that exactly answered your question. I thought you were going to say something about analogy, because I was, when you were talking this morning, I was thinking, I mean, you could think of this as, you're using the word in, and you're using it with this crazy reference object, the gizmo, and you want to know whether the child then thinks of that thing more of a container. We actually have an experiment that we haven't even designed yet. It's an idea, but if you introduced an object, an ambiguous object to a child, and you used in with it versus on with it, would they then think that things in that category that you used in with have to be more container-like, and things that you used on with have to be more support-like? That would begin to say something about that you're actually being driven by a sort of a core meaning of the preposition, and you're trusting that to
Yeah.
construe your reference object in
Yeah.
a way. And so you're,
Yeah.
you're changing your representation of the reference object.
That's a nice idea.
Yeah.
I think that's really nice. I bet you would see a change over
Yeah.
learning, where
Yeah, exactly.
as the representation of the sort of general, let's say the representation of in gets stronger, it would have a bigger effect on interpretation of the
Yeah, and
reference
I
object.
think it always really strikes me that when people, I've done this myself, so I'm certainly not criticizing anybody, but it's so easy to say, yeah, that makes sense to say in my mind, because my mind's like a container, but that just doesn't help. So, and how that actually happens, it's probably driven from the preposition. It's not driven from thinking of the mind as a container. We don't do that to begin with. It's actually by the combinatorics again. So.
I think it's just a follow-up question on Peter Gradenforth's question. I was also intrigued by the idea that one of those concepts is symmetric and the other one is not symmetric. So, the concept like A and B are connected is kind of symmetric, whereas A is connected to B is non-symmetric and kind of mean tight.
So
It's used in those tight situations.
So depending on what verb you use, you can actually do a diagnostic that tells you whether it's truly a symmetrical verb. And one of the best diagnostics is whether or not you can drop the NP at the end. So if you say Susan connected the dots were connected is fine. You don't have to repeat, or they connected. Susan connected with Mark, Susan and Mark connected, and so you can prune, you don't have to say with each other. And so that's the diagnostic of what constitutes really a symmetrical.
You mean the Gleitman and Gleitman?
Beg your pardon?
You mean the Gleitman and Gleitman?
Yeah, that's what I'm talking about, yeah. That's Lila's analysis of it.
Yeah, but if I understand correctly the claim, they mean that at the heart, those concepts are symmetric by this test. But when you use the transitive form, it gets some sort of asymmetry from the construction.
Yeah. So there's some debate, but yes, that's right. So there are certain verbs like connect that are, what other people call them is intrinsically symmetrical. And it shows up in different languages with the intrinsically symmetrical ones, not in English, but intrinsically symmetrical ones are different from ones that are symmetrical but not intrinsically. So kiss is not intrinsically symmetrical because you can kiss one person without having the person kiss you, right? So you can use it either way. So John kissed Mary on the cheek.
What I wonder about is how this is connected to your data, actually.
Okay.
Does it mean, did you see a clear preference for the transitive form in the
In the asymmetrical ones. Yeah.
Well, yeah, I don't know if it's asymmetric because Gleitman et al. Actually claim.
It's an asymmetrical event. So it's not the verb. It's in the asymmetrical event where one thing is being held and the other one is moving towards it. So when people see that, or they see this thing and they see it taken out, it's an asymmetrical event. And then the question is, what verb and what frame do they use for that? as opposed to this thing that is just the event itself is a symmetrical event.
Fine.
Yeah.
And you didn't check correlations with the kind of variation they used in the verb form, in the verb construction.
With the kind of what?
With the kind of construction that the verb.
We did. I mean, so what I presented here was just the verbs, right? Just the verbs. So the distribution of the verbs by themselves, and then the frames. But what I didn't give you that you're asking for is the matrix that says verbs and frames.
Yep.
And that we haven't done, but I know what it would look like. I mean, basically, it's going to. What you have to do is you have to do verbs and frames, but then you also have to put in a third dimension, which is the event. So what you're going to get is these clusters where when it's an event of a particular type, you get symmetrical verbs and a particular kind of frame. And when it's an asymmetrical event, you get other kinds of verbs and other kinds of frames. And then there's stuff in the middle. But that's what we'd have to show you. I think that would be the piece of data that you would want to see. Is that right?
Yeah, I need to see the data to understand what correlations you're talking about. But you do know about correlations also in the frame that people choose for a given verb.
For a given verb, the use of the frames, the distribution of the frames, yeah.
Is in correlation to the asymmetry or symmetry of the event.
So, I mean, yes, it is. But they're tendencies. They're weaker than very strong. So like put can be used with together. So you should put the beads together, right? And so put's an asymmetrical verb for sure, right? But as soon as you say put NP plural together, those are the pieces of the equation, the predicate part that expresses the symmetry of the event, right? Maybe we can talk afterwards. I don't know if I may not be being clear enough. Okay.
Any other questions that are really quick? Yes.
Hi, I really appreciated your more comprehensive investigation of the descriptions of these events, and you're right, it'd be really interesting to see a similar thing investigate how the pronouns and verb frames and so forth are combined in Korean for these same events. So I'm curious, given that you found an asymmetry in the end between Korean and English, what you would predict if such a study was done for Korean?
What we predict for what?
For Korean, would it use these other things differently as well?
I think they do. I mean, that would be my prediction, is that actually the same mechanics apply. They won't be exactly the same because the language is different in other ways, but that basically the same kinds of devices are probably used across all languages. And so the fact that you have, sort of some more verbs that can express tight fit is sort of neither here nor there. It's fine, but the prediction would be, if there was exact equivalence, you would predict that you'd get stuff along the line of equality once you added in the effects of the noun phrases and the frames for Korean. Yeah. So that's the prediction, but it's a very strong prediction.
Okay, thank you very much for that presentation.
The laser pointer? Sure. Is that yours? Yeah, it is.